trig equation for theta. And again, when you're solving a trig equation, you're looking for an angle or angles in my restricted domain that make this true. All right, you know, I've had some students say, oh, I have two things that multiply together and they equal 1. That means one of them has to equal 1. No, remember, that little trick only works when that's 0. Because when you multiply numbers together and get 0, one of them has to be 0. When you multiply numbers together and get 1, one of them doesn't have to be 1. One could be 5, one could be 1/5, right? Okay, so that's not going to work. And gosh, that's a double angle. So that's just a whole different animal. But as soon as I see a double angle, I'm thinking trig identities. I've got a whole list of things. In fact, I have one here. A whole list of trig identities. And lots of times when I'm solving equations, I first want to do a substitution using a trig identity to make it easier. So let me just look at my list of trig identities, specifically functions of the double angle. And I'm seeing here that the sine of 2 times an angle is exactly the same. It's equivalent to 2 times the sine of that angle times the cosine of that angle. Oh, that's just a trig identity. I just replaced that with that right off of my trig identity reference sheet. Let's see, is that going to help? Now I have this tangent. Oh, I have an idea. Do you have the same idea? I can rewrite tangent in its basic ingredients of sine and cosine. If we recall, tangent is defined to be the sine of an angle divided by the cosine of an angle. I think we're going to get somewhere here. All right. Is that going to take us somewhere? Oh, I think so. Look. I could think of this as all over 1, correct? I think there's some dividing I can do. I think I can divide out that cosine of theta. Alrighty? I think I can do that. And now I have 2 sine of theta times sine of theta, which is just 2 sine squared theta. Of course, that just means sine of theta quantity squared equals 1. Ah! So sine squared theta equals 1/2. I think I can take the square root of both sides. And remember, whenever you take the square root of an expression with a variable, you end up with plus or minus the sine of theta equals the square root of 1/2. And I'll throw the plus or minus over on the other side. That's usually how we see it. And let's see, square root of 1 over the square root of 2. You know, this is looking super familiar. Just for fun, I'm going to rationalize this, which is something we often do, multiplying it by a fancy form of 1, just so that the denominator is a rational number. Oh yes, look at that, square root of 2 over 2. That's one of my nice ratios from the unit circle. Sure, that is a 45-degree angle when I have the square root of 2 over 2. Or, since we're in radian land, pi over 4. Okay, and if I have plus or minus, that means the sign is either going to be positive, square root of 2 over 2, which it is in the first and second quadrant, or negative square root of 2 over 2. Sign, of course, is negative in the third and the fourth. So I have 4 answers. All 4 answers, of course, I can get from my little reference angle of pi over 4. So my solutions are going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, let's just write all those down here. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. 4 answers. And of course, I could check these by substituting each one into my original equation, and I should get something true. All right, let's say that I did not recognize this from the unit circle, although I certainly hope that you are recognizing this. You could, of course, also ask your calculator, because really what we're doing by just knowing the angle is we're undoing the sign. And if you recall, the way we undo any function is to take its inverse. Arc sine. Sometimes we call it arc sine or sine -1. The inverse takes your ratio and gives you your angle. So for example, if you just wanted to take the arc sine or inverse sine of square root of 2 over 2, you could ask your calculator to do that. Of course, you want to be in radians, since that was my restricted domain. So go to mode, make sure you're in radians. Then second sine square root of 2 divided by 2. Oh my goodness. Let's try this, okay. And my calculator gave me about 0.7853998. Yeah, well, if now I just do pi divided by 4, I realize, yeah, that is pi over 4. That would then be one of your solutions, and you could use that reference angle to find all 4, okay? But in math, of course, we always like exact answers. So rather than decimal approximations, whenever possible, you want to leave your nice exact answers. Okay? Alrighty. I think these are fun. They're kind of like logic puzzles.